Hello, my name is Wagner Souls and I'm here today talking to you on behalf of the BMW Gait about smart insoles for gait assessment. I would like to start off by telling you a little bit about a huge problem that affects 2.3 million Canadians every day, and that is gait impairment. Gait impairment can be a consequence of a variety of conditions: Parkinson's, stroke, orthopedic complications, and also diabetes. In fact, out of those 2.3 million people, 345,000 of them experience peripheral neuropathy due to diabetes and have limited sensory perception on their feet, getting them prone to foot ulcers and then amputation. It is a fact that regardless of very high or lower risk, all those 2.3 million people demand gait monitoring and would vastly benefit of that gait monitoring being performed continuously. However, there's a problem. The equipment available today for gait monitoring is not very portable. Instead, it's very expensive, fixed in specific platforms, specific locations such as high-end labs, and demand very qualified, skilled professionals to operate them. It is true that some solutions start to arise today with portability and low cost as alternatives. However, they're very poor in the signal and reliability of information they provide, and they're not very durable. In the end, individuals with gait impairment and limited sensory perception are still in need for an efficient tool to monitor their gait, and not only that, to also offer them some feedback on their performance. In this scenario, we propose flexible pressure sensors embedded in smart insoles for continuous gait monitoring. And we propose doing that using parallel plate capacitor model that would have the ability to sense pressure changes that would narrow a gap and then lead to capacitive value changes that can be translated into electrical signals, then relayed through smartphones, for instance, in the form of alarms, alerting people of risky behaviors. That would all be performed and offered to people at a low cost and durable fashion. Our solution then offers portability, comfort, and durability. It is much cheaper than alternatives currently present in the market and has a simple production. It's not relying on any highly qualified individual to be operated. Any person can just buy them and use them. It offers real-time data tracking and feedback offered to a cell phone in a very accurate fashion. As for the execution, we would have two facilities. The first one, a chemical-based facility, would be the location where pressure sensor layers would be mass manufactured and layers would be then integrated into the insoles using Bluetooth, battery, and accommodating all the devices, all the different parts necessary for them to work properly. Then the electronic boards would be programmed for data to be refined and offer reliable information. As in a separate facility in the warehouse or distribution facility, packaging and shipping would be carried out. In that facility, sales and quality assessment offices would also take place. Local, mostly online sales would occur there, product representation, and customer services. As per the business plan, we proposed a hybrid model relying on business-to-business approach and business-to-customer approach. The business-to-business model would focus on retail partners, pharmacies such as Shoppers Drug Mart, supercenters such as Walmart, and rehab centers. In terms of the business-to-customer model, we would target both healthy and clinical populations, rehab centers, and online shopping platforms where we hope to have a strong presence, such as Amazon. As for the revenue projection, instead of focusing on the 2.3 million Canadians that need it, we would rather target the 345,000 individuals with diabetes and peripheral neuropathy, in addition to the 20,000 new stroke cases every year, adding to 365,000 individuals, potential buyers of our product sold at $99.99. That would lead them to an amount over $36 million, which we know is unattainable because that would represent 100% of that niche, and that is not our target as of now. Instead, we are focusing on 5% of that niche, which would represent about $1.8 million a year, and that is our initial target, our initial revenue perspective. Finally, our solution represents a significant advancement in the assessment and improvement of balance, gait performance, and core mobilities associated to peripheral neuropathy. An initial investment of $50,000 is estimated to develop the initial version, and we hope that by winning this competition, it will allow us to give the first step towards the translation of our concept into an effective and successful product. Thank you.